So today we talk about risk analysis, and we're going to specifically talk about one tool for risk analysis, which is an FMEA. Have most of you done this before? Heard of it before? Okay. So this is not the only tool to do risk analysis. So people would say it's not the best tool, but I will guarantee you it is one of the most common tools. You all have to do this at some point in time. So we'll talk about the what, the how, the when, the why to doing an FMEA. You'll hear some other names for this same thing. FMECA, a FEMA, a FMEA, a DFMMEA, a PFMEA. These are all in the same family of analysis. So the only thing we won't talk about is where to do an FMEA, because I don't care. So an FMEA is a step-by-step approach toward analyzing what all the possible failures would be. When we talk about failures, say failures of what? It could be a design, if you're making a product. It could be the manufacturing method you're using to build the product. It could be something like a service. You really could do an FMEA on anything that has risks. So FMEA, two parts. The FM, failure modes. These are the ways or modes in which something can fail. So another way of saying it's any of the errors or defects that your product or your service or your process could have. Okay? And then the effects analysis part is looking at it failed, so what? What happens now? Okay? So it's the consequences of those failures. So you may say, why perform a risk analysis? You want to prevent injury, so some products can injure people. You want to prevent product failure, so if you're thinking about something like the GM ignition switch, that kind of a failure should be in a FMEA somewhere or FEMA. You want to prevent commercial failure, so if you have a device that has a function that doesn't work, or it's supposed to do something and it doesn't work, that can be a commercial failure. And you also want to reduce business risk, because if you have a commercial failure, or if you have an injury in your product, it can hurt your business. So if you think about something simple that you would never think to do a risk analysis on because it's not dangerous. So say like an SD card, right, a little memory card. It's not going to shock you. It doesn't put out radiation. There's really no way it's going to hurt you. Maybe you could say a child could choke on it or something like that. But it's not something you think of as being dangerous or scary. But from a 20-year-old child could choke on it. But if you think about from a business standpoint, say you're SanDisk and you make millions of those cards, right? And so you put out one card that anytime it gets below 30 degrees Fahrenheit, it erases the memory for some reason, right? That's a product risk and it's a business risk. Because if everyone counts on you to store things and data and you do that and you fail and you put a bunch of those out, you ruin your company's name and no one's going to buy that product anymore, right? So that could put them out of business if they made a failure like that. So even those kind of products that don't seem dangerous and the things that you guys are making for your community partners that don't seem dangerous, they still have risks, even if they're not injury risks, okay? So when to do this? You want to do it early and often in the design phase. So in design, as soon as you get specifications, you can start writing your FEMA, okay? So you can start thinking about risks, and you think, I don't know what my design is yet at that point in time, because you're not supposed to. And that's okay, because if you have a specification, you know risks associated with it already, right? So if you wrote a specification that this table needs to withstand 400 pounds static load, right? That's the specification like we've talked about. Well, why does it need to support 400 pounds? Because if it doesn't and I sit on it and I'm 400 pounds, I fall through it. Or if two of us that are 200 pounds, we fall through it and we can get hurt, right? So you had implicit in that specification a risk, probably more than one risk, okay? So as you guys are thinking about your specifications, there's risks associated with them that are completely independent of your design. And then as you go through design and you get an actual embodiment of what your device might be, you'll see new risks that'll appear that are device dependent or design dependent. And you want to include those as well. So this is not something you do just at the end when you're about to send it out the door. I'd say most EPICS students, if you do it at all, you do it, right? Like, we got to deliver this thing, but my advisor said we got to do a risk analysis, so we do it real quick. So that's not the way to do it. Specification driven. Another time you'd want to do this, especially a PFEMA, which is a process FEMA, looking at how you make something and how that can cause failures, whether they are failures in the manufacturing process, that would cause you to incorrectly make the device, or whether they would lead to design risks. Anytime you do a process change or before you start a manufacturing process, you'll do the same type of thing. And the example that I'll show you in a minute is a process FEMA. Next one is when you're reviewing an existing product or service. So when you design something in industry, you'll do post-market surveillance after you're done, okay? So you'll launch this product on January 1st of some year, and then you're gonna say, I'm gonna check every 6 months and look at surveys or complaints, or there's some metric that you're gonna use to figure out how you're doing in the market. And when you do those repetitive, repeated, scheduled reviews, you wanna go back and look at your FEMA and say, the failures we had, did we account for them? And are they occurring at the level we expected? Or are they occurring more often and we need to do something to change it? And then when failures occur, so if you have a large product failure, something that you have in the field that you don't want to be repeated, you can go back and do this risk analysis again. See, why did this happen, something we didn't expect, look for the root cause and try and change it, okay? Everybody follow me so far? Still wondering what is a FEMA? Okay, good. So we're going to get into an example of how to do a FEMA, and that will make it really obvious as to what this is. But first I want to introduce this concept of a risk priority number. Okay, so an RPN, or risk priority number, is just a metric that you can use to say which risks are the most important, so that when you go through and analyze your risks and try and find ways to deal with them, you can look at the most important ones first, because if those change your design, that may affect the risks that you have downstream of that in terms of the risk priority number. So risk priority number is just a product of 3 quantities. These are usually on a 1 to 10 scale. Sometimes people will assign values to this scale. I usually find that it's very difficult to quantify those. So severity, how serious are the consequences, okay? So if you're building a bridge, right, the bridge collapsing and everyone on the bridge falling through it, that would have a high severity. If you have a step in the walkway and someone could trip over that, that might have somewhat lower severity. Make sense to everybody? So what that is, 1 to 10, all is dependent on what your product is supposed to do. So if you're looking at a business risk, you know, the risk of us losing money may be a huge risk. If you're comparing that to a safety risk, it might be small. But that's why you need to scope your FEMA so that you know what you're talking about, so what that 10 means. Because 10 in one case, if you're building a nuclear reactor, may be completely different than if you're building that SD card, okay? Or even in the same product, whether you're looking at a process or a business FEMA, or if you're looking at a design FEMA overall for safety. So the next one, occurrence, how likely is this to happen? So when I say people assign scales to these, a lot of times they'll say, if it's between 1 in 10,000, 1 in 100,000 chance of occurrence, it's a 7, and it goes on that way. But usually the data to assign your risk into one of those isn't there, so you end up guessing anyway. So most of the time, you'll just say 1 to 10 and use good judgment, okay? So the last one is detection. Sometimes detection is left off, and in fact, most of these that I've done, we haven't used detection. That's usually in a process FEMA when you use detection. So that's saying, this thing is severe and likely to occur, but we're very likely to catch it before it happens and prevent whatever that outcome would be. So you take severity, occurrence, and detection, you multiply those 3, and that gives you a number. If each of those is between 1 and 10, that'll give you a number between 1 and 1,000. If you're leaving out detection, it'll be a number between 1 and 100. And then you'll set some minimum acceptable number, okay? So you'll say, if the sum of, or the product of those 3 numbers is under 100, we're not going to do anything to bring that score down. If it's above 100, it's an unacceptable risk, and we're going to do something to reduce the risk. Okay. So the purpose of doing this is to be able to take action to reduce the risk. Okay. So every product has a risk, every service has a risk, but you want to reduce those big risks down to an acceptable level. So start with the highest priority. So now I'm going to show you, and I'm going to navigate to this instead of just going to this link to show you where this is. There is an organization called the American Society for Quality. And they are asq.org, I think. Thank ECN for defaulting me to MSN so I get the slowest possible homepage. It resets. My profile doesn't work. Yeah. It's not going to let me do this, huh? See if I can get to Google. There we go. So the American Society for Quality is asq.org when that works. So ASQ is a very helpful organization. It's a society for quality engineers. So those of you who were with me last week, we talked about 3 different types of engineers that you'll see very commonly: design, manufacturing, and quality. Okay. So this is the Quality Engineer Association here in the United States. If you go to the Knowledge Center and then go to Tools, I'm showing you how to navigate to this so you can use these. They have a whole bunch of quality tools in here, and these are things that you guys should learn about at some point in your engineering career, and you'll use some of them. So things like Gantt charts that we talked about in one of the earlier lectures. They have an Excel template in here. You shouldn't use Excel to do these, but if you insist on doing that, there's a good template in here, and it actually does make it a lot better than if you make those from scratch. So if you've heard of like an Ishikawa bone diagram, things like that, there are many of these in here, design of experiments templates, but we are looking for failure modes and effects analysis. So here's a template. They also have a web page. So if you want to know more about FMEA, they've got a nice succinct set of instructions here on how to do this. It's a couple of pages long, but it's not too bad. So I recommend that when you go to do one of these, you go there and take a look, because they're giving you free tools. And the template will look something like this, okay? So when we go to do our example here in just a minute, or our little project, you're going to navigate to this same website and pull up this template and then go from there, okay? So those of you who have computers, this is where you're going to need to go for your team. So there's some basic information here at the top. I don't know if I can get rid of some of this toolbar so you can see better. It'll be all right. But what you need to fill out are your item name. So what is this DFMEA about? What is the model? So that's just what version of the product are you working on. Who is the core team? So when you go to do a risk analysis, you should never do this alone, okay? This should always be a team effort. So everyone who's involved in your product should work together. So you guys are going to break up into 4 teams in a minute and do one of these. So again, we talked about design engineer, manufacturing engineer, and quality engineer. Here they call these engineering, which is the design, production, which is the manufacturing, and quality. So again, you see at least you have those 3. Now usually you'll have marketing, you'll have sales, you'll have all these different functions represented, because each of those people come with a different viewpoint on the product and what could happen to make the product fail. A lot of times you'll assign a DFMEA number. If you work in a company, they'll assign that to you. And then you'll date it and have a revision. And the revision is important because you're going to update this as you go through your product. So when you do the design specifications, you'll do it. When you build each iteration of your design, you'll go back. And then when you do post-market surveillance, you'll keep doing it. So you'll keep revising this. And like I said, this example is a process FEMA. So we have a process function. And you always start with a function. So if it's design, you'll start with a design function. So in this process, they're drilling a blind hole. If you don't know, a blind hole, there's a hole that doesn't break out through the backside, so you can't see. It's not full depth, okay? So they're saying, in drilling this blind hole, that's our function, we have 2 potential failure modes, the hole being too deep and the hole not being deep enough, okay? I would say there's more, the hole being too wide or too narrow, or in the wrong place, or at an angle. There are many of them, but 2 examples they give you are too deep, not deep enough. And then the potential failure effects, if it's too deep, you could break through the bottom side. So this would be a through hole instead of a blind hole. They assign a severity to that. They're saying that's high severity, so that would cause the product to fail most likely. So between 0 and 10. Potential cause could be improper machine setup. So you set up to drill this hole and you set your z-axis wrong and you drill all the way through. That could be the cause of failure, saying the occurrence of that is fairly low. They have current process controls. So again, if this is a design function, it's not going to be a process control, but you may have some controls or a risk mitigation technique. So this could be something like if you're worried that that table was going to break, you test the table and you find out that it's low. That actually would be setting the occurrence down. But if you didn't know that up front, you could use that as a way to check. And then detection, they're saying the detection here is pretty good. So in detection, a small number is good because you're multiplying the three factors together. So small number is good. So when you multiply 7, 3, and 3, they get a risk priority number of 63, which they're saying is under their threshold because there's no recommended actions. Okay? Does that make sense to everybody, kind of following the line of reasoning? So you could do this with anything. If you were running an event and you had a booth to check in, you could have risks associated with this. You'd say process function being, register new participants. Risk or potential failure mode could be not enough staff to register all of the registrants. And you'd say, what is the root cause, and go through that way. So you can do these same kind of things. You could have a process control that if the line is more than 5 deep, you pull in another worker, things like that. So anything that you're doing, you can do the same type of analysis, anything with risk. So if we look at another example here in this blind hole, if the hole is not deep enough, it could result in an incomplete thread form. So if you're tapping the hole, you don't get enough threads. They have 2 different causes here. So this is an example where you have the same failure mode, but 2 different causes, one being improper machine setup and one being a broken drill. So they're saying the severity is the same because it has the same effect, but you have 2 different occurrences, one that is high, or one that is low and one that is high. And then detection, they're saying, similar to the improper machine setup before, it's not likely to happen, or it's highly likely to be detected. A broken drill, if this is an automated process, may be very hard to detect. So if you're making these 1,000 an hour and you've got a robo drill doing this, you might not know this happened. So when they multiply 5, 5, and 9, they get a 225 score, which is above the threshold. So now there's a recommended action. So you'll say install tool detectors. So this is something, a sensor that would let you know that tool is broken. And now you're saying my detection went from a 9, which was unlikely to detect, to a 1, very likely to detect because of that sensor, and it dropped the RPN down to 25. So does that make sense to everybody why when you have a high RPN, you want to do some kind of action to drop it? Okay? Everybody follow that? Okay. So that is the basic concept. Didn't take long at all. So now I want to jump into this little project. So divide into 4 teams. The 4 team leaders, raise your hand real quick. Okay, everybody see who those people are? So match up with one of them. There are about 15 of you, so go in about even teams. And we're going to have 4 products, and I will let you guys pick which one of these you want to do as long as each team does a different one. So we can have a webcam, and these are all going to be from a design perspective, okay? So that you're not looking at how to manufacture it. A webcam, a smartphone, a canoe, and a hydro jetpack. Okay, so other 3 teams, who wants webcam? Who wants smartphone? Who wants jetpack? Smartphone? Okay. Webcam, jetpack. Webcam back here, you've got jetpack, hydro jetpack. This is a water-powered jetpack. Okay, so what I want you to do, divide into teams, pull up that template, and fill out as many of risks as you can think of. Fill that template out as much as you can. I'm positive in 10 minutes that you won't have as many risks as you should have. Oh, sorry. The login EPICS, password EPICS ... Okay, so I'll give you till even on the hour at 5 o'clock. Okay, go. So if you forget, asq.org. You guys finding it? It's running almost as slow for you as it was for me up there. I'll go ahead and give you till about 5 after, since I think people are a bit slow getting loaded up.
Yeah, we're still in process.
Okay. Oh yeah.
Oh yeah, hey, good call.
Or do you remember PAL guest or guest setup? PAL guest network freshman year.
So you guys have PAL 3.0. When I started here, it was just PAL.
PAL 2.0.
Hey, are you good at reading that? Do we follow the suggestion?
Yeah, let's
What
just go
do
with
you
it.
think?
Let's just go with it.
Yes or no? Which one's yes?
Can we do a FEMA on this?
Do you know which one's yes and which one's no?
No. Have you guys got to the? You're still getting on the internet, huh?
Yeah.
You can always do it again.
Going away from it.
Hey, there you go.
Oh yeah. Perfect. I like how they misspelled too.
Hey, they're quality engineers. You can't expect them to proofread.
So
What'd you say?
professional.
What was the website
So
again?
we are a
What.org?
design
Something,
function.
some Q. SQ. Or ASQ.
ASQ.org.
What?
Where's the Q
Oh,
at?
this is all in.
It's a QWERTY keyboard, if that gives you any hint.
So it's like the end, right? Down by the M. Okay,
We'll follow your
training tools? Where was the tools?
Knowledge Center.
Because this is weird.
But is that like?
Well, this side of the room is already winning so far, if that's encouraging. Your side. Given both the teams are larger. It's not still in Chinese, is it?
Yes, the whole of Excel is in some type of Asian language.
We don't even know if it's Asian language. We just know that
It's character driven,
yeah,
right?
it's character based.
Yeah.
Okay.
Yes, you're in a safe boat of saying that it's probably of Asian origin.
I mean, all you have to do is type in the boxes. What do you guys need to understand Excel more?
No, we're in
Ah.
read only.
We don't know how to.
Didn't one of you guys have a laptop?
Hey Jim, can I have your laptop?
No.
Please?
Just double click down there. It won't let you do it
I
either.
love how we picked the canoe.
Yes, you did.
Of course.
Building a concrete canoe.
Just create a new sheet and copy the headers. Just copy that little section and then paste it in a new sheet so it'll be editable.
Yeah, I got you.
Are you sure that's gonna work? 'Cause
Okay.
I don't think it's just this one that's
Do what now?
for
Record
language.
video.
I think it's.
Well, we can get out of read only and just
Yeah.
have a blank Excel file.
The content of the Excel sheet is still, you just go to Excel and hit new.
Type in Excel.
File new there. That's
not
mail.
new.
One of those.
Open.
No, go click on the one below. Okay, go farther down. Nope.
Let's print.
I'm glad you guys are learning so much today. What if you go up in like the Excel menus?
Open up a new Excel. Just type in Excel.
Just Google how to change the language in Excel.
Potential failure.
Google is still in English, isn't it?
Yeah. Well, it was. It might have changed now.
Just type in Excel down there. Open up a new one like that.
We killed Excel.
Types of failure. Fails to record.
Wait, so what happens if you click on the first or the second one?
This is an unanticipated failure.
Alright, okay. I think
We
Excel.
put that as one.
the card could be attention node.
We should change ours to an FMEA of Excel.
FMEA.
It is ruin hardware.
I have no idea. Just do it on the chalkboard.
By solder.
That'll work.
Chips.
Alright, then do you want to type this?
No, I'm busy.
You guys are gonna be out of time.
Doing what?
Yeah, really?
What are some potential problems?
Oh my God.
No, even
Why
it's
is
all of
everything
the office
so
suite
weak?
that's in.
It's all of office.
At the minimum, we will fix the
Help
computer.
and support, maybe? Yeah, all of that is in.
Oh, I think I got a scholarship from there.
Wait.
Are they the one that, don't you have like a vending machine that dispenses, like an old Pepsi vending machine that dispenses like brew here or something like that?
We don't have a house.
Oh, must be a different house then that has a towel.
There's a lot of those.
Yeah. One of them that has a towel in it. That also
Okay, so what are these other potential effects of overheating? What'd you say before?
is free liquefied with solder. I.e. Xbox 360.
Anything else from overheating?
Well,
All the insulation off the wires
Go back
from
on there.
shorted out.
Okay.
I'll do it. Well, I'll go to the board.
Do we have enough power to make it that wall? Why are we doing this way? So we can see what it is.
At least we picked the Canoe.
Let's say I grabbed the wrong computer.
At least we chose the Canoe, so it won't be as bad.
Open it up from there.
I'm gonna have to delete your lecture credit. Now you're gonna really be in trouble. No, no, of course not. It's not your fault.
We're trying to fix the computers.
I mean, I guess you would look at it more like if there's something that's like beneath them, they can fall on. Like if they're a red boat, like they like accidentally hit if they're launched up. Yeah. If they launch up.
You guys got 5 minutes. So let's go with simplified approach. Do risk, occurrence, severity, and just bang those out as quick as you can.
However that scales.
Between 1 and 10.
Alright, well, the most obvious one would be too thick or too thin.
No,
Well, actually, or too heavy. The width would be like it sinks, and then we have an option for why it sinks.
potential causes.
Sure, yeah, okay, when it's too heavy, the material is too thin, so it's easily puncture. It sinks. Is that how they break it down?
Yeah, I think so.
Okay,
Yeah.
weight, or no, they have it, okay, hold to the potential effects.
So ours would be it sinks, and then the failures are why it sinks.
No, the process is,
Because we're doing design instead of process.
okay, we're doing design. Okay, that's Canoe, now we're down
So
at
no,
sinks.
failure would be it sinks. Design is,
Yeah, is the Canoe, is our Canoe.
yeah.
So then it sinks,
And then we got multiple.
potential effects. Yeah, and then, okay, now next one we'll say it's too heavy.
Or did you look at too heavy hard pole? Pole.
People said that things like
Or design, so it's like over. Not aerodynamic enough or not.
yeah, when nobody's gonna go.
Yes.
Good point. Because we're not the most. Or whatever.
Capsize. Weak material just like breaks and hands fall apart. Brittle, speed along with this.
That's for too heavy, for reasons for being too heavy.
All right, jetpack team,
Thanks for
you guys want to come plug your laptop in up here?
Something could
Okay.
be, like, something in the material could be water, so just dissolves.
And then we're pushing it there, but Colin should do this. The other one depends on how you make it. It's too front heavy or too back heavy or something around, but that's capsizable, I think.
But their office language was awry.
Well, I mean,
It was a character-based language of some sort.
you get wet,
On the computer?
Yeah.
you know,
Yeah.
so
It's like wasting money.
I mean, you could, I think the idea behind this is you have this,
I think you have to do
so you're about to go
like
over a
function.
or you're in the
Yeah, do function. For, if you do it one more time, it'll probably show you on both screens.
Because they had for drilling a hole, drilling a
No?
break.
Okay. Well, just throw it up there then.
consequences, severity, so they're very serious. I would put that as 8 or 9. Yeah.
Oh, there you go, both. Good.
Occurrence, how likely to happen.
Okay, so here's where you have the severity, occurring. Like, so the lower the too heavy. Isn't severe a little bit? Since we were into the process, the design, so it has severity, cars, like, those can lie the same. That's, I mean, that's probably.
Guys, you got about 60 seconds.
Thank you.
Okay, how many just ignore the hit safe? I just say those are like 4. If it's too heavy, that's saying if it's a hole, it could help. But else.
All of the consequences are there, so yeah, let's do it that way.
Okay, so if it's too heavy, well then that's. Well, if the design itself is okay, then the only thing is it's going to be like getting it in and out of the water. As far as it floating around, unless it's made out of concrete and it's poorly designed, its severity is relatively low. A hole and capsizable and brittle, those are high.
Yeah.
But for too heavy, I don't know, 5. So for a hole, let's. Capsizing. I put this one as a 9 and these two as 8s. And the hole is like this.
Yeah, that's a good one.
Okay, how likely is it to happen?
A hole is probably the most hole in the curve. You could get a rock.
Yeah, okay.
Too heavy is probably not gonna fit. Too heavy is hole probably.
Brittle, I'd say, is pretty low too. And probably heavy.
I would think that brittle would be higher up because there's a lot more causes for it to be brittle.
Yeah,
We should probably just put the fact that it's the height of the itself. They'll probably get that from the school and down there.
I prefer like a, how likely are we to catch it? Well, if the edge is pretty good.
All right, guys, don't worry about detection right now. All right, so everybody's gonna present their FEMAs here real quick. You'll get about 2 or 3 minutes apiece. So be brief about it. But I'll have you guys go through, and then I'll show you an example of a failure of your device, and we'll see if you've managed to account for it. Okay? Go ahead.
Okay, so we are the hydro jetpack. This is our FEMA. Our first thing that we consider is taking in water from the environment. The first problem we saw is that what if there's limited water in the environment? If there's limited water, then you'll run out of water and you can't fly or use it as much as you can. The potential effect from that is falling. No one likes falling. That's obviously high priority, so we give it a 6. This can cause from poor location choice. If you use a puddle rather than a lake, then we have to account for that poor location choice. There's also unwanted debris. What happens if you get dirt or rocks or something other than water inside the machine? Occurrence of that, as long we thought it wouldn't occur too much as long as the user chooses a nice location. So we gave it a 2. What we decided to implement was specifying the water depth needed, maybe in like an instruction manual or something like that. And because of that, it would be fairly easy to detect as well. So we gave it a 2. We gave it a 24. The second thing we considered was propulsion, just plain taking the user off the ground. There's not enough propulsion. That is a problem because you also can fall. You can also collide with objects in the environment like trees or boats that are like 10 feet tall. Crashing this stuff isn't also, so we gave it a high severity, 8. It could come from the unit having low suction, not taking in enough water at a high enough rate. We felt that occurs can occur quite often, so we gave it a 5. So what we tried to implement was something to monitor pressure within the machine. We did not have enough time to cover detection, so right now it's at 40, the RPN. And we also have considered what if there's too much propulsion, or also what if there's sediment or other debris inside the machine. Again, not enough time. And that's about it.
All right, very good. Yeah, great job, guys. Okay, let's check and see if they accounted for the failure that we see occur. We'll go. Here's a nice guy with a hydro jetpack. He's really smiling. He's happy. Oh no. So for time, I'll try and skip through this, or smartphone team can head up and start plugging in. But so as part of their risk control process, they put a kill switch on the jetpack. And in his excitement to take off, he hit the kill switch as soon as he took off, dropping himself into the water. So smartphone guys, you guys can go ahead and head up. Looks like fun, right? So I would say no, nobody accounted for a kill switch because you didn't design one in, but didn't design in a kill switch, so that's probably bad too. All right, smartphone team.
So we devised a feeder model for the iPhone. The first things we considered was the outer casing, which would require CAD modeling for the outer dimensions. So what can potentially happen is due to incorrect dimensions, it might not get manufactured correctly, due to which all the components might not have a tight fit, like the inside and the outside might not match up. So it's a pretty high severity case, and the occurrence is we chose it as 5 just because it's an average number. It's not as usual to occur, and current process controls entail documentation and various checks on the design process and the manufacturing process, and detection is fairly high. That's why we plugged in 2 as the value, and the risk priority number is 70 for that particular case. Do you want to go next one?
Sure. So the next thing we looked at was stress analysis, and if you use the wrong material, you could have a broken phone. So we said that's pretty severe because no one will be happy with a broken phone, and that would be because of bad decision making in which materials you use. And one of our teammates said that you can use X-ray to check the phone before packaging. So all those multiplied are 40.
The next process we considered was the phone temperature. So failure mode is that your phone could overheat, and that would result in your phone either catching on fire or melting in your pocket, which is not good. So we gave that a severity rating of 8 or 9. This is due to poor thermal analysis when the phone is being designed. And a process control would be to do simulation of the tests of the thermal control systems in the phone before actually putting them in the phone. And they have an RPN rating of 81.
The next analysis that we looked at was the phone software, because the phone software is one of the major things that needs to work before, because if it doesn't work, then phone is kind of useless. So the potential effects of the failure is unhappy customers, because if phone software doesn't work, then the phone itself doesn't work. And the potential causes and mechanisms of failure would be the faulty programming, and we gave occurrence of 3. And current process controls, we did testing the code, because we can test the code to see if the phone works, and we gave 2 for the detection. And then we have the RPN rating as 42.
Very good. So a couple of things to note. Good job, guys. So you guys had a very interesting set of things here. So some of these were sort of design-related issues, and some of them were more of the design process issues. So both of those are very good and should be considered. And this was a tough one because a smartphone is so complex. You'd have thousands of risks associated with it. But usually you would want to separate those out into 2 different analyses, but really good, really good broad thought process. Another thing I'd point out is, I think you guys got a little further than the other teams, which is good, but your current control processes, you kind of treated those like you would treat the recommended actions. You're saying, well, we wanted a low RPN, so we did this. But you kind of want to think about the current controls as we haven't done anything yet, or this is what we already have in place. So we know that our business has this control, but we want to add some more specific control, right? Does that make sense? So you want to give yourself that beginner's mind for the first set, and then when you do your recommended actions, that's where you want to think through those things that you guys put in your process controls. But very good. Great job, guys. So let's see if they caught their failure. So somebody's playing some music on their phone, left it on the bed. And the dog gets kind of excited. And then the dog eats the phone. So I would say stress strain analysis part here with the broken phone, you guys might have had it covered. It's very good. So don't play hard rock if you have a husky and leave it on your bed. So I don't know that you had chewed on by dog as a failure mode, but you were pretty close. Very good job. All right, so on to the next team, which is, what have we got left? We got Canoe team. Canoe team, you're up. So Canoe team doesn't have to mess with the computer. You guys might want to go ahead and plug your computer in up here so it's ready to go when they're done, because they won't take a really long time.
Old school, you want to,
Ha ha ha.
We'll bring it up here and plug it in. I'll wake up.
All right, so the biggest challenge we dealt with was the fact that our Microsoft Office was in some kind of Asian language, and so we couldn't get out of read-only mode. So we decided to go ahead and strip it and put it on the board as quick as possible. And so a couple of the problems that we discussed with in the design, the preliminary design of this canoe, is that the canoe could end up becoming too heavy. The joke always being that the canoe was made out of concrete. The other option was that the canoe could create a hole in it. It could be capsizable based off its design. If it hits a certain wave that would be common in a certain location, it would actually flip itself just in the way that it is. Or that the canoe itself could become too brittle and could, instead of just getting a small hole in by hitting the same rock, it could actually just completely rupture. And so I'm gonna let the other people discuss the severity and occurrence.
So when looking at severity, we thought that a canoe being too heavy wasn't very severe because usually you'd make it out of wood, and if you made it right, it's likely not going to be too heavy. Whereas a hole, because that is a pretty big problem with canoes, that if you got a hole, that's very severe, so we gave that a 9. As well as being capsizable and brittle, because those are two large issues. So that's what we represent as catastrophic failure. If you had a hole, it was capsizable or brittle. So that's why we gave those as pretty high severity ratings.
All right, for the occurrences, it would be pretty obvious to be during the design process if it was too heavy. Like you said, they're normally made out of wood, or it's going to be, I don't know, if it's like a kayak style, maybe Kevlar or something like that. And if it's too heavy, generally you're going to notice that as soon as you make it. So the odds of that happening are pretty low. A hole, on the other hand, that is a pretty, that can be a pretty common thing. You can have the strongest wood, but it depends on, the rock or whatever you hit. So the occurrence of that is a lot higher. Now with capsizing, that kind of falls under more of the design process. And so however they shape the canoe itself, that would determine if it's capsizable or not. And normally I think, with the modeling that we do, it would be pretty obvious to see if it can capsize or not. And with it being brittle, it's a little higher than capsizing, but again, that's something in the materials that you would not normally associate with wood. Especially how you treat it and whatnot. It's not very often that it's just going to break in half. So those were our 4.
All right, very good. With limited resources. Very good. Let's see if they caught the failure mode here. Nice day out on the canoe, out on the open water. Oh, and a killer whale knocks the boat over. They had capsizing in there. I don't know if you counted for an orca hitting the side of the boat.
Yes.
That would be a scary afternoon.
Wait, it didn't flip him over though.
All right.
Just hit it.
Goes an orca, I think.
Part of it shipped off, I saw it.
Huh?
Part of it shipped off.
All right, last team here.
Alrighty.
Can you put it up on the screen?
Well, the computer's got turned off.
Oh,
It's
not
installing
coming back up.
And I think it's starting to
All right.
turn on now.
Cliff note version.
Yeah, I'm going to do my best to just remember it. The first problem we had was that just structural failure. If the outer case were to be too, was not supportive enough, anything from the webcam falling off the computer it's on, or the desk it's on, or being chewed on by a dog, or accidentally hit or whatever, could cause it to break open. A direct result of that could be anything from an electrical hazard, if how you just have a bunch of exposed parts with electricity running through them, all the way up to just it breaking entirely. The result of that would absolutely be something between the manufacturing aspect and the design aspect, just whether the case was designed correctly. I mean, really, realistically, all 3 of them, because it would definitely rely under the quality. I think it's starting up now. It would definitely rely under the quality control test to make sure that it isn't susceptible to being chewed on by dogs. Other than that, the computer's really slow.
It's all right.
It's installing.
There's not really time anyway.
So yeah. On top of that, they have any hardware component in it could fail. Anything from a lead not connecting properly to just literally anything in the image processing unit. And then that would basically just cause it not to work. On top of that, we put overheating on there. Hopefully your webcam isn't overheating, because if so, that probably means it's like in a fire or something. Webcams are not particularly susceptible with that. And bad things that would come with that would be like stuff burning. It could burn the user, or it could basically just like break it if we were to like remelt the solder or anything.
All right. Thank you very much. Great job. So you guys who have laptops, drop them off. So user failure on this last one. I just want to remind you, as you guys are going out, that when you're doing a risk analysis, it's not just about how the device could break. There are other failures. So as a designer, it's your job to make something that meets user needs, right? That you meet their expectations, and that you think about how the user will use the device. We do human-centered engineering. And so you can fail in designing a webcam if you don't meet user needs, even if it doesn't break. So if you have a user who's expecting to take a still photograph with a webcam,
Here it is. Oh, we gotta wait. Here. 16, 15, 14, 13. Here, get closer. Did you hear a click? Did you hear a click? No. Oh, now, did you hear a click now? No.
so you can see you can have a clear failure for your user without the device breaking at all, working perfectly as you designed it. All right, thanks everybody. Have a good weekend.